Okay, I'm going to walk you through a great geometry problem involving a lot of algebraic calculations in the topic of what we call coordinate geometry. We're going to find the distance between parallel lines. If Ms. Fisher's geometry students want to follow along, it's on the back side of your note sheet. And we're going to start with a couple easy ones just to get the idea of what is happening here. So starting off, I'm going to graph line L and line M, both x equals equations. Hopefully you're remembering that x equals 4 or x equals any number is going to be a vertical line. So I'm right here on x equals 4, slope is undefined, and then I've got x equals 0 is actually your y-axis. So I should do a little labeling here. That's line L, that's line M. And I'm supposed to find the distance between the two lines. So, like I said in class today, very easy when you've got vertical and horizontal because we can count two ways on our coordinate graph. And one of those is horizontal. So distance between the two lines, I want to measure straight across perpendicular to both lines. And because that's a horizontal line, I'm going to count, and I'm getting 4 units for that distance. Okay, it doesn't matter, by the way, where we measure. We could measure at any point between the two lines. They're never going to intersect. That distance remains constant. Second one, just to give us an idea, I've got y equals -3, and you probably guessed what's happening here. I switched up. Now we've got horizontal lines. Y equals M, or y equals 5 is line M. And the distance between line L and line M, hopefully you're counting, and I'm getting a total of 8 units for that distance when I count. Things are really nice when we've got vertical and horizontal lines. But you're probably already guessing it's going to get more complicated when our lines are diagonal in some way in our graph, and we can't just count across or count up and down to get the distance. So that's what we're going to look at in example C. It's going to take a few steps. I'll walk you through it. Let's start by graphing. Okay, you should be familiar with graphing lines. They're already in y equals mx plus b form. So I'm going to plot my y-intercept and then walk my slope up 2 over 1, up 2 over 1, and I'm getting something like that. I'm freehanding a little bit here. That's okay. Graph doesn't have to be totally accurate. For line L, line M, I'm going to color code a little bit just so we can keep track of things. Line M, y equals 2x minus 1. Walk my slope a little bit, and that's line M. Okay. Hopefully you can see that they are parallel. Just a quick refresher. Slopes of parallel lines should be the same, and you'll notice we have 2 for both our slopes. Okay, plus I told you they were parallel, but you should see right from the equations there that we have parallel lines. We want to find the distance between them. I'm just going to pick a spot and kind of picture the distance between those two lines. Remember, we got to be perpendicular to both lines, just like we were in the first one. And in the second one, I didn't mark it, but we were perpendicular to both lines there as well. So going down here, I'm going to say there are 2 really good choices. I want to go with points that I already have. I also like to pick easy points. So I'm going to say that either of your y-intercepts would be nice. We've got a y-intercept right here. We've also got the other one down here. Just for the sake of being on the same page, I'm going to start with this one, and I'm going to picture, okay, perpendicular to both sides would be, both lines would be something like this. And I'm going to look for that distance as my final answer there. Okay, so thinking ahead, I want to find distance. I have a distance formula that we reviewed earlier this year. All I need is 2 points. I can plug in my distance formula and I will have my answer. However, right now we only have 1 point. We picked one coordinate point and we picked one of our y-intercepts. Y-intercept was 0, 3. So I now have 0, 3 that I can plug in there, and I'm going to jot that down just as kind of a reference to go back to. The other point is kind of the problem here. The other point that I don't have, which is right here. And I don't know if your graph looks better than mine, but on my graph, I really don't know exactly where that point is. It doesn't even look like it crosses on a nice point. So herein lies the work, is we need to find that point. So ultimately, I'm going to be thinking of this as the intersection point of line M and another line, which you probably don't see as a line yet. The other line being if I extend it, whoops, the line that contains that distance that I'm trying to find, the line that's perpendicular to that line M. So let's put a name with that line. I don't care. Pick a letter. I'm going to call it line P right now. And that point that I'm trying to find, my other point, which is ultimately going to be plugged into my distance formula down here, is really the intersection of line P and line M. Now we can find the intersection of any two lines we want by solving a system of equations. But I need to have an equation for both lines. I already have an equation for line M right here. I need an equation for line P. So that was a lot of talking to get to my first step, but hopefully I gave you kind of a goal of what we're getting to. Step one is going to be actually to write the equation of line P, or I'm calling it P, whatever you called that line that's going through that distance or containing that distance. I'm going to do a little bit of thinking right now. What do I know about line P? Do I know a point that it goes through? Do I know a slope of line P? Either one of those would help me when I go to write my equation. Okay? Do I know the point? Yes, you do know the point. If you look closely, the only point we know for sure is on line P is the y-intercept that we picked, and that would be my 0, 3 right here. I do know that's a point. I specifically made the line going through that point. Okay. Other option is we could have done it down here, and we could have said, hey, let's find the distance right down here, and then we'd be looking at a different line. So just to throw out there, this isn't the only way to do this problem. But let's stick with what we're doing. Slope of line P. And to get my slope, I need to think about the relationship between P and M. I specifically made P perpendicular to M because we always measure distance at the perpendicular. So I'm going to go up to my equation for line M, and my slope of my equation for line M was a positive 2, but slopes of perpendicular lines, opposite reciprocal relationship. So instead of 2 over 1, I'm going to change it to 1/2 and put a negative in front of it, and my slope's going to be negative 1/2. Okay, again, I'm converting the slope of line M by taking the opposite reciprocal since P is perpendicular to M. I'm going to go ahead and solve for my equation of my line P. Y equals mx plus b is how most of you are doing it. If you were using point slope formula, that's fine. Use point slope formula. You can check your answer at the end. I'm going to put in my y and put in my x from my coordinate point. I'm going to put in my slope, negative 1/2. And I should be able to solve for b. 3 equals negative 1/2 times 0 is just 0 plus b, so I'm getting 3 as my b value. Final answer then, y equals negative 1/2 x plus 3 is my equation of line P, which I was asked to do in step 1. So step 1 is complete. Equation of line P, y equals 1/2 x plus 3 when I plug in my y-intercept. Okay, perhaps you actually realized that our point we were working with is a y-intercept, and you jumped right to that without doing y equals mx plus b. Good for you. I did not realize that, so I made a little more work for myself. Now, I can use my distance formula once I have 2 points. Right now, I still only have 1 point, but I'm on the road to finding my other point. I'm going to bump this down and come back to it. Before we can do that, I'm going to have to go back and use my 2 equations that I have and solve the system of equations to find the intersection point between line M and between line P, which is the equation that I just got. So let's write it out so we know what we're doing. lines, I'm sorry, M and P, just to make a little point something out here. Line L and line P, we know the intersection point is right here at 0, 3. So there's no need to find that one. I'm trying to find this other point that I had a question mark for right here. That's what I'm trying to find. Okay, so I'm going to grab my two equations. Line M is one of them. I'm coming up here, y equals 2x minus 1. And then line M, or line P, I'm sorry. Line P is what I just found in step 1. Has an equation of y equals negative 1/2 x plus 3, assuming my work was right in step 1. Still not ready to use my distance formula. We'll get to that. And let's go ahead and solve the system. Two ways to solve a system of equations algebraically. Okay, and those are substitution or elimination. Either one will work just fine. In this case, nothing's ready to eliminate. I could easily multiply one equation by negative and get my y's to cancel. Instead, I'm going to go ahead and show you substitution. They're both solved for y, so I can essentially set the two equations equal to each other. So I'm going to take my 2x minus 1 and say that that is equal to my negative 1/2 x plus 3. Okay, think of it as you're taking the equation right here, and instead of y, you're putting in 2x minus 1 since we're told y equals 2x minus 1. Let's go ahead and solve. So I'm going to start by multiplying the whole thing by 2, get rid of the fraction. 4x minus 2 is equal to a negative 1x plus 6. 5x is equal to, add 2, and I'm getting 8. And you're going to think you did something wrong because you're getting a fraction answer. That's okay. Fractions are allowed. I'm getting x is equal to 8/5 as my first answer. Okay, or part 1 of my solution. Remember, I'm trying to find a coordinate point. Okay, now let's go back to one of our two equations. Please tell me you're going to use the first one because it's a lot easier. Y equals 2x minus 1. 2 times my x value is 8/5. Plug that in. Minus 1, and 2 times 8 is 16/5 minus 1. To give me one fractional answer, I'm going to change my 1 to a 5/5. 5/5 is the same as 1 whole, and that's a pretty sloppy 5/5. 16 minus 5 is giving me 11/5. Again, you're probably going to think you're wrong, so you get a fraction answer. 11/5 is correct. And I'm now ready to say that I have my second coordinate point that we were trying to find from the beginning of this problem so that I can use my distance formula. You just found it. So let's give ourselves a little more room here. Hopefully you have a whole sheet of paper in front of you. First point was 0, 3. That was my original intercept. My new point is now x equals 8/5. And y equals 11/5 from my solution to my system of equations. Graphically, if you want to take a look, it should make sense. 8/5 and 11/5, if we do a little estimation, 8/5 is what, 1.6, I believe, and 11/5 is 2.2, so I'm over 1.6 up 2.2. That seems about right. Okay, use your graph just to kind of check your work, make sure you're in the right range. Fortunately, step 3 is the easiest part of this problem. As we get to step 3, we have everything we need. We are simply going to finish the problem. So step 3. Find the distance, and I already have the 2 points there that I'm going to find the distance between, and I'm just going to plug in my formula. Okay, remember x's first and then y's. Just keep your x's together and your y's together. So I'm going to have 8/5 minus 0 is my other x, subtract them and square, plus subtract your y's and square those. So my y coordinate is 11/5 minus 3, and again I'm going to square that. Okay, ultimately we can't get an exact answer for a radical problem if we do have a fraction. So at this point, just to make life a little easier, if you want to go to a decimal, that's fine. 8/5 is really, we said 1.6, and 11/5 is really 2.2. So if you want to change it to decimals, go ahead. I'm going to get negative 0. Whoops, sorry, looking at the wrong one here. I'm going to get 1.6 quantity squared plus a negative 0.8 quantity squared. Use your calculator, plug it in. 2.56 plus 0.64. Remember, negative squared is a positive. Giving me a square root of 4.2, which is approximately, again, we can't get an exact answer, approximately 2.05 if I round it to 2 decimal places, or we can leave it as radical 4.2 would be the only way we could keep this in exact form. Not a nice way to rationalize this like we can with whole numbers. Okay, just a quick recap. Steps 2 and 3 should look very similar to the problem where we were finding the distance between a line and a point, because I'm solving a system to find a point and then plugging in my distance formula. Step 1 was actually a little easier than the other problem because I only had to write one equation of a line. I already was given an equation of line L and line M. So we wrote the equation of line P so that we could then solve the system between P and M and find this point right here. That ended up being, this point ended up being our 1.6, 2.2. And that's the point that I ended up plugging into my distance formula with my original 0.3 that I chose. I hope this helps as you work through some of these problems. Be patient, be careful with your algebra because there's a lot of places you can make mistakes. Use your graph as a reference to make sure that things look right and things are in approximately the right place. It can help you catch some mistakes. Good luck.